Okay, so for this problem, we're going to talk about doing like basically Riemann sums and integration rules and some things like that. So let's take a look. It says Joanna jogs along a straight path from 0 to 40. Her velocity is given by this differentiable function where t is measured in minutes and v of t is meters per minute. So pay attention to the units, because if there are units, you will have to make sure you write them down. Okay, first question says use the data in the table to estimate the value of v prime of 16. So we want to find the derivative value at 16. Again, we don't have an actual v of t function that we can find the derivative value. So we're going to have to approximate the derivative doing average rate of change. So if you take a look at your table, find the two closest values to 16, 12 and 20. Okay, and you're going to do v of 20 minus v of 12 all over 20 minus 12. And as you work that out, you'll end up finding that comes out to be 5. But again, remember, you have units provided for you, and think about the fact that v prime is basically acceleration, so these should be acceleration units. So it should be meters per minute squared, or meters per minute per minute. Okay, definitely include units. Those would be a necessity when it comes to that. Okay, so then for the next part of this question, it says using correct units, explain the meaning of the definite integral, the integral from 0 to 40 of the absolute value of v of t in the context of that problem. So that has to bring your mind back a little bit to motion. Integral of the absolute value is the distance something has traveled. Okay, so let's first do the explanation. Integral from 0 to 40 of the absolute value of v of t dt is the total distance, okay, traveled by, who is the person? Joanna, from t equals 0 to t equals 40 minutes, okay, in meters, because that's how far she's actually traveled. So now to actually use this Riemann sum to be able to actually do this integral, you're going to want to set up like a number line. You're going from 0 to 40, and it specifically is saying using the 4 subintervals indicated by the table, okay? So you're not going to do necessarily equal subintervals. You have to use only the points that are given to you in the table. So if you take a look, that's 0 to 12, 12 to 20, 20 to 24, 24 to 40. So those are not equal subintervals. So that means that you're not going to be able to just factor out the common base. You're going to actually have to do base times height plus base times height plus base times height and so on and so forth. So this first one has a base of 12. The second one has a base of 8. The third one has a base of 4. And the last one has a base of 16. So now also pay attention to the fact that this is the absolute value of the velocity. So each of your function values have to be absolute values of the velocities in that table. This is a right-hand Riemann sum, which means you're using the right endpoint for the height of each rectangle. So in the first one, it's the height based on the function value at 12. Okay, so that your height is the absolute value of v of 12, okay? And then the next one, the absolute value of v20, and the next one, absolute value of v24, and then the last one, absolute value of v40, okay? So your function values are your heights. So when you set up this calculation, it's 12 times the absolute value of v12 plus 8 times the absolute value of v20 plus 4 times the absolute value of v24 and 16 times the absolute value of v40. Okay, so base times height plus base times height and so on and so forth. I think you should probably write that out first just as part of your calculations and then go back and pull the values from the table. V of 12 is 200, so 12 times 200 plus 8 times 240. Okay, watch the next one. That has to be an absolute value, so 4 times 220, not negative 220. And then finally 16 times 150. Okay, and when you add all of that together, that comes out to be 7,600 meters. Okay, so now even though I know you wrote meters in the previous part of the explanation, I would still write that she traveled 7,600 meters in that 40 minutes of her running. Okay, so let's get into an alternate version of integration stuff. So instead of just using Riemann sums to approximate, now you're actually going to use integration rules to do like velocity and acceleration and stuff. Bob is riding his bicycle along the same path from 0 to 10, Bob's velocity is modeled by v of t, where t is measured in minutes and v of t is measured in meters per minute. Find his acceleration at t equals 5. Okay, Bob's velocity is b of t, so maybe you want to call it v sub b. That might help. Okay, so his acceleration would be the derivative of that, v prime of b, in other words, b prime, and specifically we want it at 5 here. So that would be 3t squared minus 12t plus 300. Sorry, not plus 300. Rewind, just plus 12t. And specifically, you're going to plug in 5. So 3 times 5 squared minus 12 times 5. And that works out to be 15. Remember, you want to make sure you include units. This is acceleration, so it's meters per minute squared. Okay. And then last but not least, letter D, it says, based on the model from part C, find Bob's average velocity during the interval from 0 to 10. So average velocity, okay, when you're doing an average value, you ask yourself, do you have the function you want the average of, or do you need to take its derivative? We have Bob's velocity. We have the function we want the average of, so we're going to have to use average value. Average value was that 1 over b minus a, integral from a to b f of x dx. So we're on the interval from 0 to 10, 1 over 10 minus 0, integral from 0 to 10 of that b of t function. So that's t cubed minus 6t squared plus 300 dt. So now, even though you have a calculator at home, I'm going to do this no calculator just to practice with those integration rules because it's important to make sure we go over them. So I'm going to have that 1/10 in front. When I take the integral of t cubed, I get t to the 4th over 4. When I take the integral of 6t squared, I get 6t cubed over 3. I get 300t. Remember, you don't need a plus c in this situation because you're working on the, with a definite integral, but had this been an indefinite integral, you would have needed that plus c. And then I would just go ahead and I would plug in my values from 0 to 10. Fortunately, I really just have to focus on what happens when I plug in 10 because the 0 is going to make everything come out to be 0. So I have 1/10 times 10 to the 4th over 4. I'm going to simplify this to make this 2 times 10 cubed plus 300 times 10. And let's say, again, I have a calculator at home, but let's pretend it didn't work or something. Imagine dividing 10 into each of these powers in the numerator and see how that would simplify your problem a little bit. So this would be like 10 cubed divided by 4 minus 2 times 10 squared plus 300. And when you eventually sum all that together, that comes out to be 350. Remember, you're talking about the value of a velocity, so it stays in meters